Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why sometimes, when you hear the same phrase over and over, it starts to sound like a song? Well, this fascinating new study dives into that very question, and it turns out it's not just about the sounds, but also about who is listening and what language they speak. Imagine you hear a short phrase like, "Hello, how are you?" and someone plays it again and again. For most of us, after a while, it starts to feel a bit musical. This is called the speech-to-song illusion, or STS transformation. But this new research from Makiko, Sadakata, and Yuzhu suggests that this experience isn't the same for everyone, and it all comes down to our native language, especially if it uses pitch to give words different meaning. The core puzzle this study tackles is why some people experience the speech-to-song shift more than others, and whether it is because they speak a tonal language where pitch changes the meaning of a word. Think of Mandarin Chinese, where saying ma with a rising tone means mother, but with a falling tone it means horse. The researchers wanted to know if this unique use of pitch in tonal languages makes people less likely to hear repeated speech as music, and crucially, if that effect only happens when they hear their own language. So, to figure this out, they recruited 3 groups of people: native Mandarin Chinese speakers, native English speakers, and native Dutch speakers. They played these groups both English speech and Mandarin Chinese speech, and also some non-speech sounds, to see how their perception of musicality changed after hearing the sounds repeated many times. They ended up with 167 participants in total, with around 55 people in each language group. They were all asked to rate how musical they found sounds on a scale from 1 to 7, both before and after hearing them repeated 8 times. The researchers used specific sound clips that were known to either strongly transform into song, like sounds after repetition, or ones that stayed pretty much like speech. They also created special versions of these sounds. This is where it gets really interesting. They took the original speech sounds and used the tool to extract just the pitch contour, basically stripping away all the actual words and consonants. This created a kind of hummed version of the speech that kept the original pitch pattern, but lost the linguistic meaning. They did this so they could see if the pitch itself, separate from the words, caused the speech-to-song effect. The experiment had a few main parts. The most important one, Block 3, had people listen to the original speech and non-speech sounds. They rated them, heard them repeated, and rated them again to see if the musicality score increased. Then there was Block 1, where they listened to the pitch-extracted versions and rated those before and after repetition. This order was important to make sure the results weren't influenced by hearing actual words first. Now, let's get to what they found. In Analysis 1, looking at the original speech, they confirmed that everyone experienced some level of the speech-to-song transformation. But here is the kicker: when native Mandarin Chinese speakers listened to Mandarin Chinese speech, the increase in perceived musicality was much smaller compared to all other situations. They found a reduced transformation specifically for their native language. As you can see in this visualization, the change from red initial rating to blue final rating is much smaller for the Mandarin Chinese listeners hearing Mandarin Chinese speech. It's like their brains were holding back that musical interpretation. But interestingly, when those same Mandarin Chinese speakers listened to English speech, they showed a normal, strong speech-to-song transformation, and the English and Dutch speakers showed similar transformation effects for both English and Mandarin Chinese speech. This strongly suggests the effect wasn't just about being a tonal language speaker, a general trait, but specifically about hearing one's native tonal language. So, why was this happening? This is where the pitch-extracted stimuli from Analysis 2 become critical. Remember, these are the sounds where the words were gone, but the pitch patterns remained. When they tested the Mandarin Chinese speakers with these pitch-extracted sounds, the native language, specific reduction disappeared. The Mandarin Chinese speakers now showed a normal speech-to-song transformation, just like everyone else, whether they heard the pitch patterns from English or Mandarin Chinese. This is a really key finding. It tells us that the reason for the reduced transformation in Mandarin Chinese speakers listening to their native language wasn't just about the pitch contours themselves. It was because those pitch contours were still actively being used by their brains to interpret the meaning of words. The researchers explained this by saying that if pitch is constantly working hard to identify words in your native language, your brain is less likely to let it switch to a musical interpretation when it hears those same sounds repeated. It's like the pitch is committed to its linguistic job. But once you strip away the words and remove that strict linguistic function, the pitch becomes free to be reinterpreted as melody. They also touched on something called native language damping, which is the general observation that speech in an unfamiliar language tends to transform more easily. But what they found here goes beyond that. It's not just about familiarity, it's about the specific role of pitch in that language. Mandarin Chinese, which relies heavily on pitch for word meaning, showed a strong damping effect for its native speakers. Other languages like Japanese, which use pitch accents but not as strictly for word meaning, show a weaker version of this effect. And non-tonal languages like English and Dutch don't show this specific native language damping related to pitch. This leads to a really cool idea about how our brains process sound. They suggest that an acoustic feature, like pitch, cannot be reinterpreted as music as long as it is actively engaged in the primary function of identifying words. The function dictates the perception. This makes a lot of sense when you think about it. Your brain prioritizes correctly understanding what someone is saying. If pitch is crucial for that, it gets a top priority signal. Only when that signal can be relaxed or its primary function is removed can it be more easily perceived as music. This aligns with a scientific idea called predictive coding, which suggests our brains are constantly making predictions about incoming sensory information. If pitch is crucial for predicting word meaning, it gets a high precision weight. This high precision makes it hard to reinterpret. But if that prediction isn't needed for word meaning, the precision can be reduced, allowing for a different interpretation like melody. Now, like all studies, this one has limitations. The participants were mainly university students, so the findings might not apply to everyone in the general population. Also, the English speakers in the study showed a relatively low level of transformation overall, and the researchers aren't entirely sure why that was, though they noted the English group was older and more mixed in age than the others. But the core finding is pretty clear and exciting. It bridges the gap between language and music perception. For Mandarin Chinese speakers, the linguistic function of pitch seems to actively suppress the speech to song illusion when they hear their native tongue. Take away the words and that suppression vanishes. This shows that our deep linguistic processing actively shapes how we experience even seemingly simple auditory illusions. So, what does this mean for us? It means that the boundary between speech and music isn't fixed. It can shift based on our linguistic background, specifically how our language uses pitch. It suggests a fascinating interplay between language and auditory perception, where the demands of understanding words can actively prevent us from hearing melody in repeated speech. It's a reminder of how profoundly our native language wires our brains and shapes our sensory experiences. And that's the essence of this study. It's a deep dive into how language and music interact in our minds, and it gives us a clearer picture of why that speech to song illusion behaves the way it does. What do you think about these findings? Does your native language influence how you perceive repeated sounds? Let me know in the comments below. And if you enjoyed this breakdown, please give this video a thumbs up. Subscribe to RUBIN'S Mind Lab for more science explained simply, and hit that notification bell so you don't miss our next episode. Thanks for watching, and I'll see you in the next one.